Good afternoon. Myself Padmakant Dhage, Assistant Professor, ENTC Department, Walchand Institute of Technology, Solapur. My topic is Continuous Time System Part 4. At the end of the sessions, students will be able to explain way of interconnections of the systems, explain basic representations of LTI systems described by differential equations, explain block diagram representations of continuous time LTI system. Contents: interconnected system, explain basic representations of LTI systems described by differential equations. Last one, explain block diagram representations of continuous time LTI system. Interconnected system. A system with input x and output y can be described by the equations y equal to h transform of x, where h denotes as operator, that is transformations. Alternately, we can express the above relationship using the notations h transform to the y. If clear from the context, the operator h is often omitted, yielding the abbreviated notations x towards the y. Note that symbols towards and the equal to have a very different meaning. The symbols towards should be read as a produces, not as a equals. Often a system defined by the operators h and having the input x and output y is represented in the form of block diagram as shown below. Here x of t given input to the system h, which produces output y of t. Two basic ways in which system can be interconnected are shown below. First one, series, that is cascaded connection. Next one, parallel connections. Here in first one, series connections, x of t given to the first system 1, that is h1. Again the output of system 1 is given to the system 2, that is denoted by h of 2, which produces finally output y of t. The overall series connected system is described by the equations y equal to h2 transform h1 of transform of x. Next one, parallel connections. Here x of t simultaneously given to the system 1 h1 and system 1 h2, which is produces individually separately output given to the summations, and finally output produces y of t. The overall parallel connected system is described by the equations y equal to h1 of x plus h2 of x, which are the transform functions. For complex transformations, we are again using next type of the connection, that is combinations of cascaded and parallel connections. Here x of t given to the system h1 simultaneously given to the system 3 h3. System 1 output h1 output is given to the system 2, that is h2. Then finally produces the output is given to the summations. At the same time, it will take the input from system 3, that is h of 3. Finally it will produces the output y of t. Next one, last one, feedback interconnections, which is used for also again for complex transformations. Here x of t given to the summations, which is given again to the system 1 input h1 and produces the output y of t. Here output part sum feedbacks is given through system 1 h2, again given to the sum, and this process is continuous, produces y of t output. Basic representations of LTI system using differential and difference equations. Input output relations of continuous LTI system is represented by constant coefficient differential equation as follows. That is summation equal to k equal to 0 to the towards n ak d raised to k dt k y of t, and b summations of k equal to 0 to the n bk dk to the derivative of dk to the dtk x of t, that is given by equations 1. In equations 1, ak and bk are constant coefficient. X of t is applied input signal, whereas y of t is output of the system. The order of the difference equations n, m represents the number of energy storage elements in the system. Always n greater than equal to m, and order is only described by n. Following example of RLC circuit can be represented by the differential equations as shown in figure. Here x of t, v of t is given as a supply voltage, RLC combinations, which is current flowing through the y of t. Suppose input voltage v of t equal to x of t and the output is the current in the loop I of t equal to y of t. Then using KVL we get v of t equal to x of t equal to r into y of t plus l into d by dt y of t plus 1 by c integrations of tau equal to 0 to the t y of tau into d tau that is given by equations 2. Differentiating equations 2, we get 1 by c y of t plus r into d by dt y of t plus l into d square dt by dt square y of t equal to d by dt x of t, that is given by equation 3. The above equations 3 shows that the order of the differential equations n equal to 2. It gives the relationship between input voltage x of t and the current generated in loop y of t. Block diagram representations of continuous time LTI system. These elementary building blocks for continuous time systems are as under. First one, adder, constant multiplier, differentiator, integrator. Here adder x1 x2 is given to the input to the summations, will get output x1 of t plus x2 of t. Performs an additions on two or more continuous time inputs. Next one, multiplier, x of t given to the input as a constant multiplier, that is give the output a of x of t. Performs multiplications by coefficient. Third one, differentiator, x of t is given to the differentiation blocks, that is d equal to d by dt, will produce the output d of dt by x of t. Perform differentiations operations. Fourth one, integrator, which having the with zero initial conditions, x of t same again given to the input block of integrator, which produces the output of integrations of x of t into dt. Performs integrations, that is exact reverse operations of differentiator. It represents the memory storage element of the system. Consider casual continuous time LTI system described by first order differential equation as under d by dt y of t plus a into y of t equal to b x of t, that is given by equations 1. Equations 1 can be rewritten as y of t equal to minus 1 by a d by dt of y of t plus b by a x of t, that is given by equation 2. Note that right hand side of the equations 2 has three basic operations, that is addition, multiplications by coefficient and differentiations. Rewriting equation 2, we get d by dt y of t equal to bx of t minus ay of t, equation 3. Integrating equation 3 from minus infinity to the t, we obtain y of t equal to integrations 2 equal to minus infinity to the t bracket of bx of tau minus ay of tau into d tau, that is given by equation 4. Equations 4 rewritten from infinite point in the time t naught results y of t equal to y of t naught plus integrations tau equal to t1 to the t bracket of bx of tau minus ay of tau bracket complete d tau, that is given by equations 5, which is the final equations. Example, construct block diagram of system described by d square by dt square y of t plus 4 d by dt y of t plus 3 y of t equal to 5 d by dt x of t plus 6 of t. Answer. First, separate out y of t from the given differential equations as follows: d square by dt square y of t plus 4 d by dt y of t plus 3 y of t equal to 5 d by dt x of t plus 6 x of t, that is given by equation 1. Then 3y of t equal to d square by dt square y of t minus 4 d by dt y of t plus 5 d by dt x of t plus 6 x of t. Y of t equal to minus 1 by 3 d square by dt square y of t minus 4 by 3 d by dt y of t plus 5 by 3 d by dt x of t plus 2 x of t equal to equations 2. Our equations 2 is used to construct block diagram as shown in below figure. Here x of t given to the constant multiplier input 2, which produces the output 2x of t, which is again given to the summations, first summations. At the same time, x of t input d by dt is given to the constant multiplier, which is the constant value of 5 by 3, which is again given to the first summation. Then output of the first summations is given to the next summation as an input. At the same time, it will produce the constant output y of t. Here at the output of y of t, d by dt again feedback given to the d by dt y of t is given to the again constant multiplier, which has the ratio of minus 4 by 3 d by dt y of t, again given to the summations. Next, d by dt, that is d square by dt square y of 2, again given to the constant multiplier, which has the constant value of minus 1 by 3. Then it produces the output d square by dt square y of t, again given to the summation, and the resultant output given to the second summations, which is again given to the constant value which produces the output y of t. References I have used: Signal and System, P. Ramesh Babu, R. Anand Natarajan, 3rd edition, SciTech Publications. Next one I have used Signal and System, A.V. Open and A.S. Wilsky, 2nd edition, Pearson Educations. Signal and System, Dr. D.D. Shah and A.C. Bagle, Mahalakshmi Publications. Thank you.